Hello everybody, welcome to our second webinar in the 49R1 series. My name is Milana Vučković and I'm the part of user outreach and engagement section which is organizing these webinars. In today's webinar, Matthieu Chevallier, our head of evaluation section, will present about new products, verification and technical aspects in our new cycle. But before I give the floor to Matthieu, I want to say a few housekeeping points. This webinar is being recorded, and if you have any questions, they will be in the recording. You can ask questions using Q&A, but at the end of the presentation, you can also raise your hand, and we can open your microphone, and you can ask the question. The recording will be available a few days after the webinar. It will be available on the implementation page, on the event registration page, and it will be hosted on YouTube. But before we start, I also have a question for all of you that I will post in the Q&A section. So my question is, what are the unknown terms for you from the Matthieu's presentation or from our other communication about the new cycle? So I will post a question after I finish, and then you can post terms that as they come that are now known to you so that we can explain these things in our documentation about new cycle. And with this, I give the floor to Matthieu.
Okay, good morning, everyone. Thank you very much, Milana, for this introduction. So it's my pleasure today for the second webinar to walk you through some technical aspects of our upcoming new cycle 49R1. Oops. Okay, this is the way. Okay, so just this timeline that you've shown already a few weeks ago when our Director of Research, Andy Brown, presented you the science which is around this new cycle 49R1. So just as a reminder, as Milana said, so you can already access the replay of Andy's webinar from the implementation webpage. This webinar was on 23rd of May. Today, so where are we? We are still in the beta phase, which is a phase on working on implementing this what comes from research into the operational framework, and also having that running until it catches up what we call the real time. Which means that now we are still the forecasting system a bit, let's say, beyond the real time, which means a few months or a few weeks behind us. So we are nearing the declaration of the release candidate phase that we foresee in July. So today's webinar will address some technical changes in IFS parameters, outputs and products, and also aspects of verification and methodological performance of the upcoming cycle. I'd like to raise that another webinar will take place in July, which will be focused more on data access, which will be at the time closer to the start of the release candidate phase. So now, let's dive into this webinar. And so here are my outlines, and I will start with a very, very short summary of what is in cycle 49R1. Again, so referring to Andy Brown's webinar a few weeks ago. So this is a major upgrade of the IFS with many very important contributions, especially related to surface modeling, physics and numerics. So I listed them here as a summary for you to have this one-stop shop to be able to access this information. So on the model changes, you have the changes in the wave model and convection packages, updates in the land surface model, the activation of the statistically perturbed parameterization scheme, which is the way we generate the ensemble through perturbation to the perturbed members in the ensemble, contribution in physics and numerics, and also a package on atmospheric composition. On the data assimilation changes, many assimilation changes with new observation, microwave, non-microwave, the 2-meter temperature package, the stratospheric balance assimilation package, also land surface assimilation, and update to our ensemble data assimilation. So all this information, many of these contributions have been already illustrated by Andy, so I won't go back to it and direct you to this webinar. Also would like to mention, and here, that alongside the NWP, numerical weather prediction upgrades. Many upgrades related to atmospheric composition will be included also in cycle 4901, and those contributions will feed into the global configurations that we run at ECMWF for the Copernicus Atmospheric Monitoring Service. So those two configurations are what we call the IFS Compo as system for forecasting, analysis and forecasting chemistry and aerosol, and also a new system which is the IFS greenhouse gas with high resolution forecasts of greenhouse gases, so CO2 and methane. I give you here as an example the impact of the 49L1 composition package, the impact on the aerosol optical depth as root mean square error over several areas, so Southern Hemisphere, tropics, and Northern Hemisphere, with 48L1, the operational E-suite, the operational suite in red, and 49L1, which is the future cycle in black, showing the benefit for this particular atmospheric composition parameter, benefits of 49L1 over many areas. I will mostly talk now about what's going on in the NWP side. So, and going now, right now, to the second part of my talk, which is about the configuration changes with cycle 49L1. So first, maybe just something that I like to raise is that there won't be changes for ensemble for the medium range and for extended range for the NWP part and the atmospheric part. No changes, let's say, in the maximum lead time of the ensemble, of the size of the ensemble, and of the way we initialize that. But there are key configuration changes, and the three are listed here, which are that the HRES, so our high resolution forecast, and the ensemble control run will be made computationally identical in 49L1. The second change is that the configuration of the medium range and extended range reforecast will change. I will explain all of that, of course, more. And the final one is that the wave model will use the same grid as the atmospheric model in all configuration. So let's go into more detail, starting with the first one that I mentioned about the HRES and the ensemble control. So during our last upgrade with 48L1, the ensemble has come to the same resolution or high resolution forecast, so at 9 kilometers, which means that now ensemble members and this HRES run have the same horizontal resolution. And among those members, there is one specific member, which is the control run. This is an unperturbed run. So basically now this run and the HRES with same resolution plays a similar role. Unfortunately, during 48L1, we have not been able, for technical reasons, to make them strictly identical. So there were still two separate unperturbed runs with different outputs. Also, they had different characteristics, meaning that, for instance, for the run started at 0 or at noon UTC, the HRES is 10-day long and the ensemble control is 15-day long, like all the perturbed members. So, but there is also another thing, is that the HRES is still disseminated earlier than the full ensemble, so the control included. For 49L1, the coming release in October, November 24, both will be made computationally identical. There will still be two runs, two different runs, but in the sense that you will have two streams of data, but they will be bit identical. And also both will run to 15 days for noon and 12 UTC. So this is really an harmonization of the whole configuration for the medium range. The trajectory is, of course, not to still run two identical runs. And for 50L1, which will be next year, next year, what we call the current control run, which is the unperturbed run running at the same time of all the ensemble members, this run will be stopped. And this data stream, which is currently called the HRES, which runs before and is disseminated earlier than the full ensemble, this will be the control run. And so just as an element, this control run will be available at the same schedule of current HRES. So for now, 49L1, to help you adapt to this trajectory, you will still have those two runs, but they will be made computationally identical, so providing the same meteorological outputs. So this is the first configuration change. The second one, which is also a big change, is the change of the configurations of the reforecast for medium range and extended range. So first, as a reminder, to be sure that everyone knows what we are talking about, what we call reforecasts, what some refer sometimes to hindcasts, those are what we call that are also named as retrospective ensemble forecast over the past years. Those are runs that forecast that has been done on past dates. So for instance, today we are the 11th of June, so runs that are run with the same configuration of the 11th of June of 23, 11th of June of 22, etc., until 20 or until 2010, etc. So over the past years. And why do we do that? Those kind of retrospective forecasts are used for evaluation purposes, and also they are used to build what kind of climatology called model climate that then are used for calibration. So in cycle 48R1, we made slight changes to the reforecast that were already available, in spite of the major changes that have been made for the forecast configuration. So the extended range reforecast runs 10 perturbed members and 1 control forecast every Monday and Thursday, so 2 times a week over the past 20 years. The medium range has similar configuration, also running twice a week. With 49R1, we will move to a different configuration, 2 different configurations for the extended and medium ranges. The extended range, you will still have 10 perturbed member and 1 control forecast, but they will run every odd day of the month. So you see on the line at the bottom of the slide, the blue squares that are, so this is a month, what you have here, and all the dates, all the blue square are when we will have access to a reforecast for extended range. For the medium range, that will be every 2 odd days of the month, which means that you see that there are less red squares at the bottom on the line. So just to say, how did we get with this these configurations? I will have another slide then after that on that. But just that this has been discussed a lot for now maybe 2 years. Especially with users, with a survey that has been sent to discuss what could be the options given the major upgrade with 48R1 that we had. And it has been, and the conclusion of that has been discussed and refined during last year using ECMWF forum, also in 23. So this is a logical completion of 48R1 upgrade, especially for the daily extended range forecasts. And the main advantages that I list here are that this, for instance, for the extended range, the increased frequency will benefit on skill assessment and calibration. I will show an example just after that. Then running on fixed days, why this odd day and fixed day of the month? Why this choice? Running those fixed days of the month, we allow for direct comparisons between the reforecast produced in different years. So, and also allowing direct comparison with the seasonal reforecasts. And finally, 2 things also, which means that, relates to the fact that medium range and extended range run over the same period of the first 15 days at 2 different resolutions. The common dates for medium range and extended range reforecast will provide opportunities for generating calibrated dual resolution ensemble products. So products using medium range resolution at 9 km and 36 km with extended range. And also they will also facilitate assessment of the impact of the resolution of this medium range. So this is a big change for those of you who use the reforecast. We hope that it will also generate more users of this reforecast set. And just to say that for those of you who use that, for extended range, we'll continue to produce the weekly products based on calendar weeks, which are weeks from Monday to Sunday, but other options will be possible also for accessing the data. So here, an example of the first advantage that I showed about how say how it, let's say it helps the assessment and calibration. So here you have the result of experiments that we made to compare the forecast skill assessment of the extended range forecast system and to compare the skill assessment of a calibrated product using the current configuration, so the current forecast calibrated using the current reforecast configuration, and compared to test reforecast configurations, which includes the one in red, which is the configuration chosen for 49L1. So basically what we hope is that by that, of course, the calibration will, a better calibration will decrease, of course, the values of those metrics, which are the root mean square error and the CRPS. And what we show here is that so we want to go to the negative side, of course. And so the lower on the negative side here, the better. And what we see with this red point, which is the configuration, is that we have a significant improvement with the configuration that have been selected. And we compare that to configuration where we have daily initialization of the reforecast, which means something which is more comparable a priori to the forecast, to the forecast configuration, and changing the number of ensemble members which are run every day, because of course we have a limitation of, and we cannot afford running too many ensemble every day. And what we show is that, of course, with a reasonable size of the ensemble, with daily initialization, it looks better than with this configuration where we have only every 2 days initialization. But the improvement is not as big as the improvements that we have with the configuration in the red, which shows that we have a good compromise with this configuration, with also a good ensemble size, which is important for calibration. So this choice, so this kind of metrics have been also shown to you at the time when discussing changes in this reconfiguration almost 2 years ago now. The next change of configuration is related to the wave model. The wave model will now use the same grid as the atmospheric model, whatever the configuration used, which means that it will be TCO 12-79 in the ensemble for medium range and TCO 319 in what we call the ensemble extended range or the monthly forecast. So it means that now the native grid for the ensemble WAM, which is the name of the wave model, will go from the 14 kilometer reduced latitude longitude grid to the 9 kilometer TCO 1279 grid. So as a result, to benefit more from this new high resolution of the wave model, we encourage users to request the wave data on the 1.1.1 degree regular lat long grid or directly on the native TCO grid with sub-area possible, rather than what is used so far. So this is the final. So the 3 main configuration changes I wanted to raise here. So now I'll move on to the new parameters and products that comes with this new cycle. So, oops. Yeah, okay. So I'll start with a summary of what I will show now. So here you have a list of these revised and new parameters. So either there are new outputs or revised, which means that outputs that already exist, but that will be a bit different from on your side, which will mean that you will have that there will be some actions needed on the user side, and also new products that will be generated to benefit from to take the full benefit of 49L1. So the changes I will talk more about convection, clear air turbulence, changes in the 2D wave spectra outputs. I'd like to mention that there will be new wave parameter, maximum wave height and crest, which have been requests from some of our member states. New products on simulated satellite image, which especially visible channel. I will talk a bit more about that because this is something new, and also heat stress parameters. I'd like to mention here also that there will be something also of impact, which will be a changes in sea surface temperature values over land. So this sounds a bit weird written like that, but this is basically the missing value that are used where there is no where outside of the sea that are used for in the outputs. And so far it was a constant which was 273.16 K. And this actually has proven to be detrimental for especially part of our for the VAR, so the assimilation part of the model. So there will be a change, which means that now the value, the forecast field of SST will be set to the value which is the best estimate for water temperature, the lake model temperature. So you will have support to adapt to that, but this is something to be aware of. So I'm coming to the different outputs and products that I've been mentioning earlier. So first, the convection. So the changes of the convection in the convection parameters occurring in 49R1 are the completion of a multi-year effort that has been made in collaboration with the European Storm Laboratory to improve the consistency within the IFS of all the convective parameters and also in the convective parameters that we output in order to better support especially the forecasters in issuing warnings on convective hazards. So the objectives was mostly to, rather than using those convective available potential energy or CAPE or convective inhibition, which is seen, to have values that are more relevant for this forecasting assessment, which are the most unstable CAPE and most unstable SIN, or mu CAPE and mu SIN. So this effort has started before 47R3, so not last cycle, but the previous one. And at the time of 47R3, so there has been an addition of new parameters, so mu CAPE, and also mixed layer CAPE for the lowest 50 hectopascals and lowest 100 hectopascals. Coming to 48R1, there hasn't been much changes. A bit of more parameters now use those mu CAPE, but for instance, you can see here that there is no mu SIN. So in 49R1, there will be a cleaning of CAPE and SIN parameters in all application products to only use the mu CAPE and mu SIN. So I provide you here examples of the implication in terms of GRIB and GRIB parameters, and which means that for 49R1, with this change, we will finally output 3 pairs representative of the CAPE and SIN, which will be the most unstable CAPE and most unstable SIN, and then the mixed layer parameters in the lowest 50 and 100 HPA. And this will be done for the forecast and also in the reforecast. This will achieve more consistency and the situation we have now, which is inconsistent with still CAPE and SIN and also most unstable SIN. So stay tuned for that, and especially this is a change that was ongoing for several years. For the clear air turbulence, so CAT, so this has been a new parameters with 48R1. I'm not going to talk a lot about that, but it has been mentioned by on the Brown's webinar a few weeks ago that the probabilistic products, the probabilistic parameters for clear air turbulence will be extended to include a new process, which is a non-orographic gravity wave dissipation outside convection areas. So need to be aware of this change. This is not a fundamental change, but one of the implications is that the CAT field will be somewhat smoother and with slightly higher values in a few areas. I'm not going to enter much more into detail into this parameter because there is no implication, let's say, on the technical side, more on the interpretation. So another revised parameter is related to the wave model, again, is the changes in the two-dimensional wave spectra output, or 2DFD. The number of frequencies in the wave spectra output will be reduced from 36 to 29 frequency. So this impacts mostly the medium range ensemble configuration, in which we output these parameters. And what happens here is that the same first 29 frequencies as before will be kept, and there will be no archive of the last 77 frequencies. So for information, the number of directions, because the 2D wave spectra is a spectra of frequency and directions, will stay as before. And so please have a note that for users receiving this parameter via dissemination, this will be automatically adjusted in your data requirement in the test system. As new product, I like to mention those products that are the simulated imagery products. So later in 23 and earlier in 24, ECMWF has launched new real-time imagery products that are available on EC charts and open charts. And those products are meant to assist forecasters who can now visualize a medium range prediction as would be seen from a visible sensor or a sensor on board a satellite. So you can see this kind of image like the one which is here on the left, which is already an image which is on the charts, available on the charts with the current cycle. So those are already available with infrared and visible for 2 channels. And you have here images that are derived from model temperatures and cloud layers, so from parameters from the model that gives an image which is basically which provides an images with clouds that also forecasters can follow with perpetual daylight. So you can also see the clouds of the day and during the night. What will happen in 49R1 is that this product will be enhanced with true color as representative for channels from the instrument which is on board the Meteosat 12. So the example of what will be bring about with this is that here on the top you have what it looks like now with the visible reflectance as being the parameter output, thanks to which we have currently this kind of image. What will come with the true color will come this kind of products that you have on the bottom right. Here with true color showing the clouds and also the kind of land surface that you have, and also being able to build some cloud composite with true colors. So this again, products that will help forecasters and also evaluation of base. So thanks to the comparison possibility to compare with satellite imagery. Finally, new parameters related to heat stress. So this also the completion of developments of a new library that has been done in ECMWF through various projects to calculate human thermal comfort indices. So those kind of indices are will represent things like buildup or loss of body heat due to meteorological factors, which means that beside air temperature, so have humidity, wind, or radiation. So in 49R1, there will be all parameters available to calculate a series of indices like wet bulb globe temperature, heat index, and so on, and the Universal Thermal Climate Index, or UTCI, which you have an example here on the kind of meteogram. And here an example on the map, which is not from a forecast, but from a reanalysis product using these parameters, which is already available on our climate data store under Copernicus Climate Change Service. So that's it for the parameters or new or revised parameters from 49R1. Then I come to the evaluation of a few elements on the evaluation of the cycle 49R1. So I'll show again the scorecards, which is this object that compares for several parameters, which are here on the y-axis, different metrics for different regions. So here I showed for the ensemble root mean square error and CRPS for North Hemisphere, South Hemisphere, tropics, and Europe. And for all those parameters, the first, let's say the top part, the upper part, it shows the verification against own analysis. And on the lower part, the verification against observation. The color code here is that for red, the experimental E-suite, which is 4901, will be worse than the control, which is our current operational suite. And for blue, the E-suite is better than the control. So what Andy Brown showed last time, and this is basically what we repeat here, is that there is mostly blue than red. I will come into more details on the blue part. Maybe just, of course, mentioning or debunking some part of the red ones that are actually understood, especially when we look at upper atmosphere or 50 HPA scores that can be related to interactions between different contributions, scientific contribution of these scores, especially the new EDA. But also what we also have seen is for the tropical scores, where we have a few of the aspects, especially against new analysis. So this has been, let's say, a compromise of different contributions and part of the tuning. And that has been that this is possibly an optimal configuration compared to other choices that would have degraded other parts of the scorecard. Finally, also for the wave score, you can see in this line here, the red line, which is on the mean wave period parameters. These are to rise during the development that we have this degradation, but again, it's understood for future training in future cycles. So again, the degradations are understood, and we will work out for, let's say, new cycles, let's say, but not for this one, of course, because now it's running. The suite is running. So what I want to show, of course, is the blue line, because those are basically the highlights of the cycle. And especially here, going to the two-meter temperature forecast compared to observations, so showing the CRPS, so probabilistic scores. And one of the highlights of this cycle is the improvement, especially for the first part, I'd say, of the short to medium range of the two-meter temperature forecasts. And you can see that here we have up to 3 to 5% in Europe, a bit less on the tropics, but also for the northern hemisphere, we come nearly to 10% improvement compared to the operational suites. Many contributions alongside the two-meter temperature data assimilations are contributing to this improvements. And I'd like to just advertise that there is a news on the website, ECMWF website, that is telling you more about the two-meter temperature forecast improvement in cycle 49L1. Another highlight of this cycle is a 10-meter wind forecast, which is significantly improved over all the lead time of the ensemble forecast here that you can see, with more than 10% also. So initially, and then coming still above 5% at the end of the at the second half of the forecast. Here, this is mostly something that can be attributed to the contribution of the SPP, the stochastic parameterization that generated the ensemble, that generates actually an improvement of the probabilistic forecast on the boundary layer, especially for 10-meter wind. I'd like to show another view of that. So this is another part of the scorecard with other metrics that are related to the spread of the ensemble. And here what you see in green is an ensemble which in the E-suite, which is less active than in the operational suite, and in purple, which is more active. And you can see that the purple is mostly on the area near the surface. We have more spread in the surface because we increase the spread in the boundary layer with the new stochastic physics scheme. And there is generally a small spread reduction in the troposphere. It's an effect in 49L1, but the improvement in boundary layer actually increases the scores, the probabilistic scores. Something about waves, because waves are one of the important contribution elements of this 49L1 cycle, with an improvement also of the significant wave height forecast that is visible. So here for the northern hemisphere, so this is observations, but it was significant wave height. By monitoring the E-suite, we are also checking if at the event so event-wise, there is so there's this improvement that we can see on the scorecard translate into the representation of let's say the weather for a side of an event. I picked up one example that I think illustrates some more contributions in this cycle, which is an urban heat island effect over London here that has been observed in January 2024. The situation you can see here with the observation on the right, you have the station in central London, which is measuring -2 degrees, and immediately in the surrounding you have -5 and -8. So basically you have here an effect that is on the order of -2 degrees, for instance. So compared to the surroundings, related to the heat island effect. And you see here in 4901 HRES the situation, and 4901 with an ensemble control or equivalent to the HRES, where it's where you have here the example where you can see basically the effect clearly visible, and especially warmer than in 4901. So there has been many contributions there, and I think also interestingly we see the lower temperature all around, and especially one of the aspects in the land surface model, which has been a lot done for 4901, the introduction of a tile, which is a representation actually of the places where you have urban, you have cities. So representation of that as a land cover, which is which has an effect then on processes in the boundary layer. So I wanted to highlight this example as an example of local effect of temperature improvement. Tropical cyclone, this is something that has been already mentioned by Andy Brown last time. I just want to provide an update. We have now more tropical storms in the monitoring and so in the verification, and you can see here two parameters evaluation. So the first one is position errors on the left, and then some measures on the core pressure errors to measure the intensity, so the intensity forecast error. So you need to be aware that the position error is we have a slight improvement for shorter time scale and for longer time scale, but lead times. But in the middle we have a slight degradation, which is not necessarily significant. But for the intensity forecast, we still are a bit negative in the impact of the comparison between 4901 and 4801. What we need to see is here the matrix which is represented here is error and spread, and what we can see here you have in the the dashed line is the spread, and the blue is 4801 and the red is 4901, and there is a significant increase of the spread in the tropical cyclone forecast. The error also is increasing a bit, but it's mostly the spread which is increasing a lot in that. And we have also, and this is something that has been shown by Andy last time, the impact of the frequency of tropical cyclone for different thresholds. And so the matrix that I've shown earlier was about all the kind of, let's say, all classes of storms, of all intensities. And what I want to show here is how does this increase of spread, let's say, translate into frequency of different forecasts. And so we have more tropical storms of all tropical cyclones of all intensities. We have related that to SPP, the stochastic physics. But what we can see is that it's beneficial on the black line here is the comparison to observations, to observed cyclones. And for 49L1, we are closer in this area because we have mostly an underestimation of the frequency in this area, which means for most severe, most intense phenomena, which is beneficial actually, of course, for the weakest systems. There is a bit of a warning here, just as an effect of this new cycle. And the final one, just a reminder of what Andy shows about the fact that we have identified also that as an artifact of the new cycle of the recentering of increased resolution and sample data assimilation. You can spot some non-asymmetric structures at t+0. So here you have the example of one of the tropical cyclone. This kind of artifact of structure resolves itself by 12 hours. And this is understood, and we have a plan to address that for next cycles. And the final slide here on evaluation, which is on the extended range for forecast. So many things here to say that actually the impact is limited on the weekly mean anomaly skill scores and also on the Euro-Atlantic regimes. Maybe we can say something more positive, see some improvement for the MGO, especially when with correlation for week 3 to 4 improved, and also the spread a bit reduced. This is actually one of the positive aspects in extended range, as this is one of the key source of predictability for monthly, so at the monthly range. Okay. Just one slide about how to access the cycle 4901 forecast. What are the plans mostly? Because just again, there will be a webinar, and then after that will be my conclusion. So first, ECMWF will operate a test suite in parallel to the operational data delivery during the release candidate phase. This will operate in the same way as last year for 4801. So some users will have direct access and others will need to contact our user services to make changes. And some changes will be completed on behalf of users. So especially anything that will break the system will be done for you. So I mentioned, for instance, one just earlier. For the reforecast, however, there will be no reforecast by default, so will not be ported over. Instead, we will comment all these portions of the code, and this will allow you to start receiving data faster, but also encourage you to think about your new configuration and start making changes very early in the process. It's because this is not straightforward to translate the previous configuration with the new one, but we want that then to make, of course, that you choose the configuration which suits better your needs. So during the test phase, you can test and change data in your system as much as you want as you need. But I need to remind that you may not use the data in your operations or commercially. So those are only test data for evaluation purposes. And when you have finished testing, you must mark your data as ready to migrate to receive this data on the day of implementation. So there will be many more information. So those are very preliminary information, and there will be many more information on the website and during the upcoming dedicated webinar that we schedule in July. Okay, so now let's get ready for cycle 4901. So just to wrap up, so cycle 4901 will bring significant scientific changes on the modeling and the data assimilation sides. So here, this is what has been presented during the first webinar. During this webinar, I hope that now I've provided you some useful information on the key configuration changes, on the revised and new parameters that will be in this cycle, and a few elements of what can be expected in terms of meteorological performance, with a few of, let's say, in a bit more practical term. Of course, now for the technical aspects on how to access the data, need to get ready, and I will start with this checklist that for you to not forget the things that you need to think about while migrating to 49L1 as soon as the release candidate phase will be declared. Of course, the 49L1 implementation page needs to be studied. You need to get the test data to check everything in your process code, to use the right C code version, and then, of course, to watch the few elements that are related to the different changes that I mentioned on the reforecast, on the convective parameters, on the SST max data, and on the wave data. And of course, during this test phase, to provide feedback. Please provide feedback or report issues via the ECMWF support portal. This is exciting time with this major release coming in our medium range and extended range systems. And there are many more to come soon afterwards, but let's do this one first. So please bear with us, follow our updates on the implementation web page, and get ready for the new cycle. So thank you very much for your attention. Thank you for the many colleagues who helped to prepare this presentation, and I'm happy to read, and we are happy to read about your questions. Thank you.
Thank you very much, Matthieu. So there were a couple of questions in the Q&A. Some were answered, and I think we can go through the ones that have not been answered, right, by Martin, our head of production. So there is a question from Dan Suri from Met Office. Which wind chill index is going to be used? Is it JAG-TI or something else?
I cannot provide this information. I think I don't know if Claudia is here or someone.
She's not.
But no.
I checked.
No, okay. Yeah, okay. So thank you.
Her,
okay, so this is kind of information that we can provide. We will, let's say, document that.
All right. Is there any consideration on adjusting Euro-Atlantic weather regimes, for example, moving from 4 regimes to more better representation in certain patterns?
Is it? I tried to understand this question from it, but maybe I don't know, Chris or Andy would like to take this one. But is it in the products that we issue for weather regime?
I think so.
Yeah. Okay. Do you want to comment on that?
Is this question to me? I guess for the plot that was shown was the sort of standard evaluation we do of the classical 4 regimes, but this doesn't necessarily have to correspond to the products we issue. This was just an illustration. We evaluate lots of things. So there was a newsletter article maybe a few years ago, led by Christian Grams with Laura Ferranti and Linus and others, comparing different regimes, including the year-round 7 weather regimes Christian has worked on. And of course, we also issue products based on this 2 EOF phase space that gives some indication of whether or not blocking or NAO types of flow patterns are more or less likely in a probabilistic sense. So whether we make changes in the future to adopt or issue additional products with the 7 regimes is I think a question for FD and the future. So they all give slightly different information and use different naming conventions, which sometimes is also a bit difficult to interpret. Often one person's negative NAO is another person's high latitude Greenland blocking. So, and one person's positive NAO is another person's zonal regime. So we've had questions in the past about how to map between these different interpretations. So I don't know, but that's really for the FD and the evaluation section, whether or not we make changes in the products that are issued. But how we evaluate things is more flexible. This was just an illustration of the impact of this cycle on those the 4 classic regimes.
Okay, thank you, Chris.
Thank you very much. So there is a next question, which is a little bit longer. Are we not concerned that the reforecast used for evaluation of 49R1 of the model and climatology calibration are not initialized by reanalysis products by 49R1 itself? Will this reforecast used for evaluation and calibration actually be representative of operational forecasts with 49R1, which will be initialized from the data assimilated with 49R1 itself?
I'm trying to see what is the information in the. I don't know, Chris, you're showing up.
I mean, yeah, I can sort of provide some answer to this. So it is an inevitable consequence of the way we run reanalyses that we will never have perfect consistency between the initialization of our real-time forecast, which will use the analysis of the day with the latest operational cycle, and how we initialize our reforecasts. So these will depend on the availability of a long reanalysis. So for the moment, our reforecasts, both medium range and extended range, we initialize from ERA 5, which is obviously a different cycle, quite an old cycle now. When we have ERA 6, we'll initialize with ERA 6, but it's just unrealistically, it's unfeasible. It's so expensive to run these reanalyses that I don't see a situation in the near term where we rerun the reanalysis for every cycle. So we have a certain degree of inconsistency, but I would say in our case, we're in a much better situation than other centers where they will rely on their real-time forecast initialized with their operational analysis and then initialize reforecast with our reanalysis. So I think we can never have perfect consistency, but we sort of do the best we can. And often for some elements of the system, we will rerun a cheaper reanalysis for things like the land surface initial conditions or other aspects where we can try and improve this consistency when there are particular changes in the system that we know are have a big impact, like the introduction of the multi-layer snow scheme or some other changes where it really is important to try and improve this consistency. So 49R1 will have a offline land DA update for the land surface component, but we have to continue to use the best latest reanalysis we have, and there can be some inconsistency, but that's just the nature of the way we have this frequent updates in real time, and it's a compromise we're happy to make.
Thank you.
Thank you. We have a raised hand, and let me try to unmute the person. Allow microphone. And okay. Sorry, I don't see full name. Asbihani from Morocco. You can ask your question.
I'm Asbihani from Morocco, DGM. Thank you for your presentation. I want to ask a question about the spectral frequencies. I want just to know if the frequencies are changed in the internal configuration of the model or just in the tracing of the spectrum.
It's just in the output. The model will still run with 36 frequencies.
Okay, thank you.
Thank you. There is a question. Is ERA 6 based on 49R1?
Yes and no. So actually ERA 6, so it's the future reanalysis so it's a future reanalysis that will be run in 2025. Will build on the science of 49R1, but with additional contributions will be made into a new cycle called 49R2, which will not translate into a numerical weather prediction configuration, but really for the reanalysis. So the science that you see here, additional will be part of ERA 6, but with additional contributions relevant for ERA 6.
Thank you. Next question is, do you recommend using beta phase from Mars in order to have more historical data sets for this new cycle? I'm guessing it's about the data sets that are available in Mars.
So I will read Martin's 30 reply. Yes, if you have access to Mars.
Okay, sorry, I didn't see the reply.
Yeah.
Thank you. Well, so we went through them all that I can see. And we still have 5 more minutes. So you can type your questions in the Q&A or you can raise your hand. And if somebody who can, of you who are answering questions, see the question before me, feel free to read them.
I don't see any. So maybe I can just a reminder of where we are, and so that we plan an additional webinar more on the access testing and practicalities closer to the release candidate phase that we expect to start in the course of July.
Thank you. Yes, we will announce the date of this webinar as soon as we know when the release candidate date is, because we can't do before. And we have another question. The ECMWF open data from October 2024 will be from 49R1.
Yes, that'll be updated as well. And we're just discussing whether we release test data of the open data as well.
Thank you. I think we can slowly wrap up this webinar. Thank you all very much for joining. Thanks Matthieu for presenting, and thank you Emma, Chris, and Andy for helping with the questions, and thanks Martin Sati for helping in the Q&A. So please follow our updates and join us in the webinar in July, where we will show you more technical updates. Oh, we have somebody raising hand. Okay, allow microphone. Yes, I don't see the name, but
is it a hand or is it Christoph?
I see a hand. Yes, maybe somebody wanted to clap hands. Okay, probably a mistake. Okay, thank you all very much, and see you in the next webinar in July.
Bye-bye. Thank you very much.
Bye.